Hey, it's Coach Latham here. We're going to continue with part 2 of expressions and operations under 15. Meant to say at the end of the last part that if you were confused at all by those laws of exponents, and we're going to be factoring some radicals here a little bit later on, that we have a whole 15-minute video devoted to that, so you can check that one out in the same area. But today we're going to start with factoring. Part 2 of simplifying expressions. We've got two main types of factoring that we learned in this class. One is called greatest common factor factoring, and what you look for there is to see if there's something that you can take out of every term. If we take a look at this number 1 here, we've got a 6 and we've got a 12, so we know that we're going to be able to take a number out of both of them because 6 and 12 have a common divisor. Their common divisor is going to be 6. And then we've also got x's in both the first part and the second part, so we can take an x out. So we're going to say 6x times something is going to be equal to 6x squared minus 12x. So all we've got to do is divide by 6x, and then whatever we have left over is what we're going to put in the parentheses. 6 divided by 6 is 1. X squared divided by x is x, so we'll put an x right there. There's a minus in between. And then for the second part, we've got 12 divided by 6 is 2, and x divided by x cancels out. So our answer will be 6x times the quantity x minus 2. Of course, you can always check your work by multiplying back out using the distributive property. All right, for this second one, number 2, this is the type of factoring that we like the best. This is basic trinomial factoring. We've got x squared plus something x plus a number. And since there's nothing in front of the x squared like a 2 or a 3, we can just go straight to the number game. We're looking for two numbers that multiply to 6 and add up to 5, two numbers that multiply to 6 and add up to 5, and the answers are going to be 2 and 3. So this one is a factor to x plus 2 times x plus 3. Again, you could multiply those back out doing binomial multiplication, and you'd see that you get x squared plus 5x plus 6. Going on to number 3, we again have a GCF problem. I know that this is a GCF problem because x's are staring at me in both terms, so I know at the very least I can take an x out of each term. So I'm going to say equals x. I'm going to open my parentheses and I'm going to divide through by x. X squared divided by x is x. I got a minus in between. 36x divided by x is 36. So there's your answer to that one. Number 4 is a lot like number 2. It may help you if I put the unwritten 1 in right here. Minus x is the same as minus 1x. Since x squared doesn't have anything in front of it, we can play the number game. We're looking for two numbers that multiply to negative 6 that add up to negative 1. Two numbers that multiply to negative 6 that add up to negative 1. It's going to be negative 3 and positive 2. Negative 3 times 2 is negative 6, and negative 3 plus 2 is negative 1. When I get down to number 5, 5 is one of those special cases. It doesn't really fit either the GCF ones or the trinomial ones, although in my brain it works like a trinomial. But it's called difference of two squares. We don't have a middle term, we don't have a common denominator, but we know that the square root of x squared is x, and we know that the square root of 36 is 6, and we make one a plus and one a minus, and there's our answer. Now this is not the way I learned it in high school because this didn't make any sense to me. The way that it makes sense to me is I'm looking for two numbers that multiply to negative 36 and add up to 0. There's no middle term. So I'm looking for two numbers that multiply to negative 36 and add up to 0. And 6 times negative 6 is negative 36. 6 and negative 6 give you 0, so that's the answer. All right, every year for the past 3 or 4 years, they've put one problem on the SOL test, like either 6 or 7. These are the ones that I would call difficult factoring. Let's see. For number 6, I don't have any greatest common factors. Even though they all three have numbers in them, nothing that will go into 11 also goes into 2 or 12. So there's nothing to factor out, which means that I've got to make my two binomials, and to make things worse, one of them's got to be a 2x and one of them's got to be an x. So we can't play the number game. We can't play the number game on this one because we've got a 2 in front of the x squared. So what we have now is trial and error. We are looking for two numbers that multiply to 12, but we're going to have to plug them in and kind of fiddle with it until we get the right combination that'll give us 11 for the middle term. Let me think about this for a minute. Let's see. If I put let's try this. Let's say I put a 3 here and a 4 here and see if that works. That's going to give me 3 times x is 3x. And it's going to give me 4 times 2x is 8x, and 8 plus 3 is 11. Yes, I have a winner. So that's going to be the factorization for that number. Again, you don't always get it right at the first time. If you had put the 4 and the 3 in the wrong place, you just work it out in your head and see if it worked. You will find out a little bit later on that there's an easy way to cheat on this using the graphing calculator so that you get one of the answers, but that'll be covered a little bit later. Number 7 is our last one in this section. 6, 2, and negative 8 are all even. So I can factor out a 2. So I'm going to factor a 2 out of this whole thing and then see what I have left over. 6x squared divided by 2 is 3x squared. 2x divided by 2 is x, or 1x. I'll go ahead and write it like that. And then negative 8 divided by 2 is negative 4. So this is what we have. I don't know if we can factor it any further, but I do know that if we can factor it further, that it's going to be a 3x and an x, because that's the only way that we're going to be able to get x squared. So let's see, 3x times x is 3x squared. We're looking for numbers that multiply to negative 4, and I need to get a 1 in the middle term. Thinking. Let's see, let's try this. Plus 4 minus 1, and see if that works for me. That's going to give me a plus 4x right here, and it's going to give me a minus 3x out here. 4x minus 3x is 1x, so this is my winner. Okay, there's almost always one question on the SOL that looks like this, where you have to model a polynomial operation. So they have these squares, rectangles up on the screen. They tell you that the big square is equal to x squared. This rectangle right here is equal to x, and the little square is equal to 1. And they say x plus 3 times x plus 2 can be modeled as. Now this is the way that I would work it out. I would just go ahead and multiply it out. X times x is x squared. X times 2 is 2x, and then we'll distribute a 3. 3 times x is 3x, and 3 times 2 is 6. When I put my middle term together, I'm going to get x squared plus 5x plus 6. So I want to make sure that I've got 1x squared down here. All right, here's my 1x squared. I'll just put an x squared there. I've got to have 5 x's down here. X, 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 x. There's my 5 x's. And I got to have 6 1's down here. 1, 1, 1, 1, 1, 1. So that models that problem. It's usually multiple choice. You'd have to find the right one out of 4 different answers, but this tells you how to find it. The last thing that's in this unit is about simplifying radicals. The first thing that we need to take a look at is the numbers that are on the right of this screen. These are the perfect squares that you're going to factor out. So we're always looking for a 4, 9, 16, 25, 36, or 100. There's other numbers in between, but we don't typically ask you to memorize those. These are the ones that we're looking at. So what's the biggest number from that list over there that goes into 75? It's going to be 25. 25 times 3 is equal to 75. 25 is important to me because I know that the square root of 25 is 5, so the final answer is 5 square root of 3. I'm looking for numbers that I can take the square root of and factoring them out. So for number 2 seems a bit silly when we get to the end, but 16 goes into 16. So 16 we can take the square root of. M to the 6th has an even exponent. That's what we need in order to take the square root. And n to the 10th has an even exponent. So there are no leftovers here. We can take the square root of all that stuff. The square root of 16 is 4. The square root of m to the 6th, you just take half the exponent. So that's m to the 3rd. And the square root of n to the 10th is n to the 5th. So there's your answer for that one. Number 3 looks more like one of the difficult problems on the SOL. We've got a 2x on the outside, and then we're going to factor the inside. Well, going into 32, my perfect square is 16. So 16, and I got a 2 left over. For x to the 5th, I need an even exponent, so I bop it on down to x to the 4th, and I put my extra x over there. And for y to the 4th, I'm good to go because 4 is an even number. So this is the part that I can take outside. The square root of 16 is 4. 4 times 2 is 8. I had a 2 on the outside. The square root of x to the 4th is x squared. X squared times x is x cubed. I had an x on the outside. And let's see, the square root of y to the 4th is y squared, and I still got a 2x left on the inside. The only thing left to cover in this unit is some cube roots. They generally don't have many of these, and they almost always have 8 or 27 as what you're factoring out. Remember, 8 is a perfect cube, 2 times 2 times 2. 27 is a perfect cube, 3 times 3 times 3. We take a look at this first one. Cube root of 8 times 2 gets us to 16, and the cube root of 8 is 2. So your answer is 2 cube roots of 2. You just factor out the perfect cube, the same as we were doing with squares. For the cube root of 81, it's going to be the cube root of 27 times 3. 27 times 3 is 81, and 27 is a perfect cube. It's 3 times 3 times 3. So when it comes out, it'll be 3 cube root of 3. Now that's everything that you need to know out of the first 3 SOLs, A1, A2, and A3. Again, watch these as many times as you need, and make sure you work with your teachers that you know how to use the calculator. Good luck getting ready for the SOL test.